Your training session has over, no?
Yes, ma'am.
Why 44 students have only joined this meeting? Uh, so, in today's lecture, we are going to discuss about CPLD, that means complex programmable logic devices. Okay, so CPLDs, these are first invented, or we can say these are pioneered by Altera. Uh, and Initially, they were called as a classic EPLDs. Okay, so that means it was programmable logic devices, but the name it was having, that is a classic EPLDs. And then there was three additional series for CPLDs, that is a Max 5000, then Max 7000 and Max 900. These are the different series that is available for this CPLD. So the CPLD, it is a, as I said, it is a complex programmable logic device, which is more complex than that of a SPLD. So that means it is a more complex than a PROM, then PAL and PLA. Okay, so from that it is a little bit complex because this has built on a, actually, it is built on a SPLD architecture only, but it creates a more larger design. Okay. So in a CPLD, there are more number of programmable logic devices that are used in a single CPLD, and so that we can get a complex design. Okay, so here we can say that as this is the extension of a PAL, that is a programmable array logic. So in a programmable array logic, as we have discussed earlier, that AND array, that is a programmable, and OR array, that is a fixed. Okay, so it has a cost lesser than that of all other SPLDs. So that is used in a CPLD. So more number of PAL that are used in a single CPLD, and because of that it has a high capacity devices, and uh, as it is not a single architecture of PLDs, right, but it is a multiple PALs that are integrated together, and that is why we call it as a complex programmable logic device, that is a CPLD. Okay, so as there are multiple PALs that are available on a single chip, and that is why we can program that PALs first. Okay, so that means there is a scope for designing all these PALs differently, and again by interconnection between them, these all these PALs, that is also programmable, and that is why we have more scope for getting a large circuit that is built on a single IC. Okay, and but as the circuit that becomes more complex because of all these pairs, and that is why it is called as a complex programmable logic device. Okay, so this is the architecture, typical architecture of CPLD. So here you can see that it has a number of logic blocks. Okay, so these are the number of logic blocks or the functional blocks that we can say, um, or that are available here. So you can see this is the PAL like block, or it may be also PLA block also, there may be possible there. So these are logic blocks that are available. So multiple number of blocks that are available in a CPLD architecture, and then with these IO blocks we can program this PALs. Okay, so there are different IO blocks which are available for each of this logic block. Okay, and then again there are certain interconnections wire which are available between these PL. So here you can have the programming at between the IO block and this logic block, as well as you can have programming between the interconnection wires and this PL. That means these connection between these two logic block that can be also programmed. So this becomes a complex programmable logic device architecture. Okay, so here in this logic block, each of this logic block that has a micro cell. Okay, so each of this micro logic block is a PAL like a block now. So it has a macro cell which contains logic uh, to implement this block. Okay, so whatever are the specialized logic operations that we need to perform, so that are present in the macro cell. Okay, so this macro cell that provides additional circuitry to accommodate all the registered or non-registered outputs. So whatever are the outputs that are provided with the additional circuitry by these macro cells, and along with this there is a single signal polarity control. Okay, so that means here this signal polarity control that provides output in the form of true signal. That means whatever is the output, the same output you will get at the or same signal you will get at the output pin, or you can get a complement of the signal. Okay, so that means if we are saying that A is the output, then A or A bar, out of that any one you can get at the output. So that is dependent on the circuitry which is available in the macro cell. Okay, so the actual number of logic block within the CPLD that varies. So now here in this diagram you can see 4 number of logic blocks that are available, but there may be many number of logic blocks that are available in the CPLD, and depending on that number of logic blocks that are available, uh, the how much design it can configure, that will be decided. Okay, so that means more number of logic blocks, then larger the design that can be configured. Okay, so large design that you can configure in a single IC, that is possible with the more number of logic blocks that are available in the CPLD. Okay, again in the center of this design there is a, here you can see that it is an interconnection wire, but it is actually called as a global programmable interconnect. Okay, so or it is also called as a PIA, that means programmable interconnect array. So what this interconnect does, it allows connection to the logic block macro cells and the IO cell arrays. So this programmable interconnect that is usually based on either array based interconnect or multiplexer based interconnect. If there is an array based interconnect, then it allows any signal within the programmable interconnect to connect to any logic block within the CPLD. Okay. So this is achieved by horizontal and vertical routing. Then if there is a multiplexer based interconnect, then it uses digital multiplexer which are connected to each of the microcell input within that logic block. So here this is the typical architecture of CPLD. So here you can see that this is the programmable logic block that are available, then global interconnect, that is a PIA, that is a programmable interconnect array, So that is present, and the IO blocks that are present in this CPLD architecture. Okay. Now let us discuss about commercially available CPLDs. So as I said that here in a CPLDs we can have uh, multiple SPLDs that are present on a single chip, and then we call that as a CPLD. So these CPLDs that are more sophisticated than that of SPLDs, because when we are using a larger circuit or when we are designing a larger circuit, then we may require more number of SPLDs to build a certain circuitry. But here in a CPLDs, with a single CPLD you can get a larger circuit, and therefore that is more sophisticated. So when we are going for the commercially available CPLDs, Altera that has developed three families, which is Max 5000, then Max 7000, and Max 9000 series. Okay, so we are going to focus on Max 7000 series because it is widely used, and also it has more logic capacity, and speed performance is also good in a Max 7000. Actually, Max 5000, that is a older version of CPLDs. Okay, so that means it is having a older technology, and it offers a cost effective solution, but still as it is a older version, so we are going to focus on Max 9000 and Max 7000, sorry, and Max 9000, that is a similar to Max 7000. So but it has a little bit higher logic capacity than that of Max 7000. So we are going to focus here on Altera Max 7000 series. Okay. So here we are, as I said, we are going to focus on Max 7000 Altera CPLD. So this Altera Max 7000, it is a family of high density, then high performance CMOS CPLDs, which is based on Altera's second generation Max architecture. So as Max 5000 is the first generation Max architecture, so Max 7000, that is a second generation Max architecture, and we are going to discuss about this series. Okay. Then Max 7000 series is widely used, as I said, and it offers state of the art logic capacity and speed performance. So that is the uh, one thing that we go for the Max 7000 series. As I said, the Max 5000 is an older technology, and Max 9000 is similar to Max 7000, except the Max 9000 offers high logic capacity than that of Max 7000. And these Max 7000 devices that are available both based on EEPROM as well as EEPROM technology. So that means electronically programmable random read only memory, sorry, and then EEPROM. So both these technology that are available in a Max 7000 devices. So if we go for the general architecture of Max 7000, it looks like this. Okay, actually it is a very complex design, or it is a complex circuitry, but here in terms of block we have shown that a general architecture. Okay, so this circuit, it has here you can see LAB, which is nothing but logic array block. Okay, so that are the different logic blocks that are available. So here you can see that there are 12 logic blocks that are available in this uh, architecture. Okay, so this here this side you can see 6 logic blocks, and here also there are 6 logic blocks. Each of this logic block that is connected to the IO block. Okay, so this uh, here you can do the programming for in between the IO block and the logic block. Okay, and then each again these logic block is connected to the programmable interconnect array, that is a PIA. So here you can see a PIA that is present in between this, sorry, uh, in this architecture circuitry, where this PIA, that is nothing but programmable interconnect array. Okay, so that means it is uh, a connection between the this logic blocks. Okay, so this is the actually circuit diagram, or you can say this is the actual architecture of Altera Max 7000 series. Okay, so there are here this diagram you can see that it is a very simple. We have not considered any signals in this circuitry, but here you can see that there are okay, so there are different logic array blocks so that are available, so which contains macro cells in that, and then there are IO control blocks that are available with IO pins. Okay, so 8 to 16 IO pins that are available to each of the IO control block. Okay, and then this can be programmed using these macro cells where there are 8 to 16 pins that are available. So here as we know that there may be multiple number of these logic array blocks that are available in this. So here just for simplicity we have shown 4 macro cells only. Okay, so for 4 logic blocks only, which are again connected with the programmable interconnect array. So this is about the architecture of a Max 7000 Altera CPLD. Okay. Now, Altera 7000 series architecture, as I said, it comprises of lab, that is a logical array blocks, and PIA, that is a programmable interconnect array, and then IO control block. So, okay. So these are the different blocks that are available on in a architecture of Max 7000 series. Okay. So this PIA that is capable of connecting any LAB input or output to any another input LAB. Okay. So with this PIA we can program in such a way that any input or output of any of the logic block that can be connected to the another LAB. So that we can do with a PIA. Then each LAB that consists of 16, that means 2 sets of 8 macro cells that are available in a max, each of this LAB of Max 7000 series. Then each Max 7000 lab has 36 inputs from the chip-wide interconnect and 16 outputs to PIA. From 8 to 6 outputs from each lab can be routed to the IO pins through the IO control block. And from 8 to 16 inputs from the IO pins can be routed through the IO control block of the to the PIA. Sorry. Here we have how these pins that can be configured that in a Max 7000. So This is a Max Altera CPLD 7000 Altera CPLD. So where the global clock input and global clear input that are connect to all microcells. So here you can see that the global clear as well as global clock that is connected to each of the macrocell. Uh, then there are two output enable signals that connect to all IO control blocks. Okay, so you can see um, the vertical lines in the logic array that are common to all of the macrocells in the lab, and the vertical lines that are B1 with programmable interconnect lines from the PIA and from shared expanders. Okay, so let us now discuss about what is logic array block in a Altera CPLD. Okay, so there are in a the most important block in a Altera CPLD, that is a LAB. Okay, so it has two sets of 8 macrocells. So here you can see that there are 6 in such a way there are 16 macrocells that are present in each of the lab, that is a logic array block of this CPLD. So these macrocells that has a set of programmable product term part of the an AND plane. Okay, so that means here with this each of the macrocell we can have a product term. Okay, so that means in other way we can say that whatever AND operations that we want to perform, that could be done using this macrocells, and then that are fed, whatever output that is fed to OR gate and a flip flop which is present in the circuitry. So the flip flops that are that can be configured as a D type, or it may be JK, or it may be T or SR, or it can be transparent also. So whatever type of flip flop that may be used. Okay, so depending on the application. So here we have a very simple structure of Altera CPLD lab. So here you can see in this diagram, you can see there are in any lab there are 16 macrocells. Actually it is 8 pairs of macrocells that are present, which shares a product term. Okay, so each of these macrocells that gives a product term which is given to the or input. Okay, then whatever is the output that is or input that is controlled by this IO control block, and then this is given to the programmable interconnect array so that it could be connected to the other LEDs. Okay, and then we can have again input to this other labs from IO pins also. So whatever is the IO pins that are available, from that we can directly connect to the programmable interconnect array, or it could be through the LAB. So we can have a different set of inputs for each of the LAB. So now this is the actual structure of LAB. So here you can see that this lag. Okay, so here there is a local LAB interconnect. So whatever is the IOP input from the IO pins, that could be connected to the labs through this and local LAB interconnect. Okay, so all these local vertical lines and the horizontal lines that shows the local connection to that LAB, and then input there is also a input from other macro cells in a lab. Okay, then that is given to the OR gate. Okay, and then output of that OR gate that is given to the flip flop. Okay, and then that output is given to the programmable interconnect array so that it could be connected to another LAB. Okay, so this is the architecture of macro cell in a MAX 7000. So, overall this MAX 7000 Altera CPLD, it has the number of inputs to the OR gate in a macro cell, that is variable. The OR gate can be fed from any or all of the 5 product terms within the macro cell, and in addition it can have up to 15 extra product terms from macro cells in the same lab. Each macro cell that comprises a set of programmable and plane that feeds an OR gate and a programmable flip-flop. These flip-flops that can be configured as a D type, then JK type, then T or SR, or it can be transparent also. So as I earlier said, so these flip-flops that may be of any type or it may be directly connection, so that may be transparent also. The product term flexibility that makes the MAX 7000 series lab more efficient in terms of chip area. So the typical logic function that don't need more than 5 product terms, and architecture supports wider functions when they are needed. So here, as there are more number of macro cells that are present in each of the lab, and that is why they are producing more product term. So here in each of the logic functions, they will not need more product terms. Okay, so because of the uh, flexibility in the product term. Okay, so here this is about the MAX 7000 Altera CPLD. Okay, so what is the things that we have seen in this MAX 7000 Altera CPLD? First of all, I will go again to the first diagram, that is it is a Altera 7000 series general architecture, where we can see that in a MAX 7000 Altera CPLD there are uh, logic blocks that are available. Okay, so multiple logic blocks that are available in a single chip, and then there are IO blocks as well as programmable interconnect array that is present. Okay, so here this program lab and programmable array interconnect array as well as these IO control blocks. So these forms a complete architecture of this Altera CPLD, where we have different connect inputs signals. Okay, so here you can see there are different input signals that are available in this architecture. Okay, so here we have in each of this lab we have a macro cell that is present. Okay, so in each lab we have 16 macro cells, that is a set two sets of 8 macro cells that are available, and there are 36 inputs that are available for each of the lab, and that 16 outputs to PI. So 8 to 16 outputs that are from each lab can be routed to the IO pins, and 8 to 16 inputs that from IO pins can be routed through the IO control to the PI. So this is about the architecture of MAX 7000 Altera CPLD. Okay, so you can check for the data sheet of MAX 7000 Altera CPLD, as well as you can check what are the different circuitry that are available for this Altera MAX 7000 CPLD. Okay, so if you have any doubt, you can ask me. Okay, so all this that will be available in the data sheet. Also, I am going to share with you notes of this max 7000 Altera CPLD, so that it will be easier to you to get a just a little idea about all these ICs. Okay, so that we are going to discuss here. In examination, there will be a question on explain architecture of Max 7000 Altera CPLD. So there you need to explain about this diagram. Okay, so here and this also you may draw. Okay, and then you need to explain about what is mean by LAB, then what is PIA and what is IOTA. Okay, so that is needed to be explained in the um, answer of that question.
मॅम किती मार्क्सला येईल हा क्वेश्चन आला तर
6 marks. Okay, okay, as your structure is like for 6 marks or 4 marks. Okay, so this will be for 6 marks. So there you need to explain about each of this block there. So anyone has doubt? Okay, this is just a theoretical part that we have explained here. Okay, we are going through just a theoretical part. We are just not going to use this in laboratory. So that is why I took it hurriedly little bit. But if you have any doubt about this, you may ask. There is one more family of CPLD, that is a Xilinx XC9500. So in the next lecture, we are going to discuss about that. But if you have any doubt about this, you may ask. We have still more time. नो डाऊट म्हणजे काहीच समजलं नाहीये की सगळं समजलं?